How's it going, everybody? Coming at you with another example problem. Today I'm going to be looking at an IVP that involves the derivative of a Laplace transform. I kind of discussed the theorem and went over a couple basic example problems in the notes, but we never did a full IVP, so I thought it'd be worthwhile to try one for everybody. The practice problems in the books and a lot of our textbooks didn't really give us a prime problem that involved the derivative theorem. So this is actually the example 2 from the Dawkins section on non-constant coefficient IVPs. I will provide a link so everybody can check that out. But again, I thought this would just be beneficial for everybody to check this one out, see how this works out in the actual process. So the main difference here is that we have the t involved with our function here. And the theorem that we're going to use to solve this is going to be, from Dawkins, it's going to be theorem 5.2.4. I'll write it out real quick for everybody's sake. So that's the Laplace of a function t to the n times f of t. And that's going to be -1 raised to the n times d ds raised to whatever n is times capital F of s. Alright, so that's what we'll be using here. Alright, so taking the Laplace transform of each one of these terms here. Alright, easy enough. Let's just go ahead. Alright, so starting with this guy, we do negative dds times the Laplace of just y double prime here. So that's the beauty of that there, simplifies it nicely. And then it's going to be plus, because normally minus the negative here, plus dds of the Laplace of just y prime plus the derivative of y, which we know is capital Y of s. And this is going to equal the Laplace of 2, which is just going to be 2 over s. No big deal. Alright, so continuing to simplify this guy, we're going to have the negative dds of just the normal Laplace transform of y double prime. So in parentheses, s squared capital Y of s minus s y of 0 minus y prime of 0. And then plus dds of this guy here, s y of s minus y of 0 plus y of s, capital Y of s, equals 2 over s. So the terms that we had over here. Alright, so I'm going to factor and simplify here. So these guys are pretty straightforward, just taking the product rule really of each guy. It's going to yield us negative s squared y prime of s minus 2 s y of s plus y of 0. At this point we can realize that that is equal to 2. I'll write it above. Right, plus s y prime of s plus y of s plus y of s equals 2 over s. Again, so that was just the product rule of this guy, and then the derivative of this, simplified, product rule of this guy, and then derivative of this guy. No big deal. Alright, simplifying, grouping like terms, rather. capital Y prime of S, we're going to have S minus S squared plus just capital Y of S. That'll be 2 minus 2S plus 2 plus equals, 2 over S. Alright. From here, we can continue to simplify. We're going to realize that this is S minus, or this can be factored to S times 1 minus S. This can be factored to 2 1 minus S. And alright, so bringing these terms over to the other side and bringing the 2 over, this simplifies to Y prime of S plus 2 over S times Y of S equals 2 over S squared. So I'll kind of break this down what we did over on the side here. So this, so bringing these guys over, it's going to be 2 minus 2S over S, and then we're multiplying that by this, or 1 over it, S1 over S. This is 2 times 1 minus S, cancel, cancel, 2 over S squared. Alright, at this point we have a first order linear differential equation, which we can solve using some of the techniques that we learned at the beginning of the year. So I will proceed as such. So considering this term here, our P of S is going to be 2 over S. Mu of S is equal to e to the integral of 2 over S ds, which simplifies to S squared. Alright, easy enough. Multiplying this term by each term in our expression here, S squared times Y prime plus S squared times 2 over S times Y, capital Y of S times 2 here, equals 2. And then considering that dds of S squared is equal to 2S, we can see that this simplifies over here to dds of S squared times Y, and that's going to equal to 2. Alright, integrating both sides with respect to S yields S squared times Y is equal to 2S plus C. Nothing crazy there. Alright, bringing S squared over, we have 2 over S plus C over S squared. Alright, this is, sorry about that, this is capital Y of S still. So to get Y of t, we need to take the inverse Laplace of this here. Alright, these are all basic terms. We're just going to have 2 plus C times T. That's good. So Y of t, this is our general solution here. Y of t equals 2 plus CT. Y prime of t is just going to be equal to C. Plugging in our initial condition, C is equal to -4. So our particular solution, Y of t is equal to 2 minus 4t. There it is. Alright, pretty straightforward. It's just a matter of understanding how to utilize the derivatives of a Laplace transform. theorem, but again, pretty straightforward. Just turns out like a normal IVP that we've been doing thus far, so nothing crazy. Let me know if you have any thoughts, comments, or concerns. Any major issues that I might have had in my problem here, just let me know. I appreciate the comments. Have a good day.